Hello everyone, my name is Monit and welcome to Eduxcite classes. In today's class, we will start paper 1 of higher level of October-November 2019 series. Okay, so let us start. Those who are from the SL, I have already made one video of the same November 2019 for the SL paper in which I have solved each and every MCQ. Today we will be doing for the HL. Okay, so the very first question. Which fundamental quantity has the SI unit of kg per meter second square, that is this one. So we have to see which physical quantity has the same SI unit as that of the given in the given question. So I have just write down the basic formulas. So half is having no SI unit, so mass is kg, meter square upon second square is the velocity square. So that is not the right answer. Mass again kg, meter per second square for the acceleration, so again the wrong answer. Momentum is mass into velocity, so mass is kg, velocity is meter per second, then again it's wrong. So the right answer is pressure only, that is force is kg, meter upon second square and meter square. So one gets cancelled, so we get kg upon meter second square as the respective SI unit. Okay, so for the first question, the answer is D. Now moving on to the second question. Two forces act along a straight line on an object that is initially at rest. One force is constant and the second force is in the opposite direction proportional to the velocity of the object. So in this case we can see, and this is the object and this is a constant force in the right hand side, and a varying force is acted on the left hand side which depends upon the velocity of the object. Okay, so what is the correct about the motion of this object? The acceleration increases from 0 to maximum. So if you see a constant force is acting and this is a varying force which increases with the velocity, so the acceleration will not increase from 0 to a maximum value. Okay, because you can see that if the force is increasing, so the acceleration, the net acceleration will get decreased because of the resultant force, that is ma will be constant force minus varying force. So this varying force is increasing, so we will be getting a subtracted value from the constant force, so the resultant acceleration will get decrease. Okay, the acceleration increases from 0 to a maximum and then decrease again, that is the wrong answer. The velocity increases from 0 to a maximum. Yes, initially the object is at rest. So when the force, constant force is acting, it means it will start to increase its velocity till the varying force become equal to the constant force. At that time the acceleration will be 0. So in that case the velocity whatever the attained by the object will remain maximum and it will travel with the same speed. So yes, the option C for the question number 2 is the right answer. You can check for the D, the velocity increases from 0 to maximum and then there is no chance of decreasing the velocity, because once it achieve the terminal velocity, that is the constant force will be equals to your the constant force will be equals to your varying force. So in that case it will become terminal velocity, that velocity will be terminal velocity and then it will not decrease. Now the question number 3. A ball falls from rest in the absence of air resistance. The position of the center of the ball is determined at 1 second interval from the instant at which it is released. So what are the distance in meters traveled by the center of the ball in each second? Look, it is highlighted, it is been bold. Each second means it is asking for that particular instant of second. For the first, it means what is the distance, or you can say displacement traveled in the first 4 seconds. That in the first second how much, in the second second how much, in the third second and in the fourth second. So using the equation as equals to ut plus half a t square. So the ball is being released, so this will be equals to 0. So we will have s1, that is half, just for taking, because you can see the values are in multiples, so we can take g as 10, t is 1 square. This is for the first second, so you will get answer as 5. Now in the second second, if I use the same equation, then I have to use 2 square. So that is for the 0 to second, that is the displacement, and that will be you can say 5 and that is 4, 5, 4, 20. So this is from the initial, but if I have to calculate for the second, then from 0 to 1 it is 5, from 1 to 2 it is 15, and you can check for others as well, and next will be 2 to 3 will be 25, and then 3 to 4 will be 35. So the answer B is the right answer. In the same manner you have to follow for all the seconds. It is asking for each second to be very precise, otherwise you will get C, that will be the wrong answer. Okay. Question number 4. An object is thrown from a cliff at an angle to the horizontal. This is a cliff and it is thrown with an angle with the horizontal. The ground below the cliff is horizontal. This is a horizontal ground. So three quantities are known about this this motion. So what are the quantities that must be known in order to determine the horizontal distance from the point of projection till it reaches the ground? So this I have already made. So what are the values we should know to calculate the horizontal distance in a projectile? So we know that horizontal distance is u cos theta times t. So we should know the initial velocity or the horizontal. This is the horizontal component. Yes, we require the horizontal component. Yes, theta, that is the initial angle. This is the angle theta, that should also be required, and the height of the cliff will be required to measure the time, because using this, let us say this is having a height h and taking downward direction as minus. So minus h equals to u t plus of half minus g t square. So for calculation of t we require the value of h. So the height of the cliff is also required. So all these three values are required. So the answer is D, that is first, second and third. All the three values must be known in order to calculate the horizontal distance. Okay. Now the question number 5. The variation with time t of the acceleration is shown. What is the change in velocity from 0 to 6? So this is an acceleration versus time graph, and we know that area under the acceleration versus time graph, this area will give us the change in velocity. So just finding out, let us say this is A1 and this is A2. So A1 is 2 into 1, that is 2, and A2 is half sum of its parallel side, that is 1 plus 3 into perpendicular distance, that is 4. So this is 4 to 8, 8 plus 2 is 10. So 10, that is the C is the right answer. That is the area under the acceleration versus time graph gives us the change in velocity. Okay. Question number 6, again, nuclear particle having the energy 10 raised to power 8 electron volt has a mass of 32 milligram. What speed must the grain of sand have for its kinetic energy equal the energy of the nuclear particle? So it is given in electron volt. First of all, I have converted that energy of the nuclear particle into joule by multiplying with 1.6 into 10 raised to power minus 19. So this is the energy of the nuclear particle that is converted into kinetic energy, that is half mv square. Mass is 30 milligram. You have to convert it into SI unit, that is the kg. So milligram 10 raised to power minus 3 and then 10 raised to power minus 3 for kg. If you solve this, this is 1.6, 10, 1, 2, 2, 2 gets cancelled. So this is 10 raised to power minus 20 and 8. So we get 10 raised to power minus 12 equals to 10 raised to power minus 6 v square. So v square will be 10 raised to power minus 6, or you can say v will be 10 raised to power minus 3. That is in meter per second, and the values are given in millimeter per second. So if I want to convert it in millimeter, I have to multiply it with 1000. So that will be 1 mm per second. So that is option A is the right answer. You have to just do the simple calculation, that's it. Okay, now the question number 7. Look, whenever you find these type of formula given, these are directly taken from your physics booklet which is being provided during the examination, so that you can compare how the question can be solved using your physics booklet. Okay. So the tension in a horizontal spring is directly proportional to the extension of the spring. So the energy of the spring having a extension is denoted by half k. Delta x is the change in the length or the extension, you can say x square. So at when the extension is x, so I can say E is nothing but half k x square because x is the extension. Now the question is asking what is the work done by the spring when extension changes from x to x by 4. So we know that change in energy is equals to work done. Work done is equals to change in energy. So change in energy is half k x square minus of half k x by 4 square. So solving this half k x square I am taking common, so I will get 1 minus 1 by 4 whole square, so 1 by 16. Solving this you will get half, and half k x square can be written as E because half k x square is given in the question as E because the answers are given in terms of E. So what can I do is I can write E 16 minus 1 upon 16, that is nothing but E equals 15E by 16, that is option D is the right answer. Okay. Next, question number 8. Again these two formulas from the thermal physics are provided. A mass m of water is at temperature 290 Kelvin. The specific heat is C. Ice is at its melting point, that is at 0 degree, or you can say 273 Kelvin, is added to the water to reduce the water temperature to the freezing point. Now a ice has been added in order to reduce the water temperature to its freezing point. It means I have to take the temperature of water from 290 to 273. The latent heat of fusion for the ice is given as L. What is the minimum mass of ice is required? Now what we are doing, we are having a mixture of water and the ice. Water is at 290 and to reduce the temperature of water I have added ice. So the question is asking what is the minimum amount of ice is required so that the temperature of the water from 290 Kelvin decreases to 273 Kelvin, that is the freezing point. So using these two, that is the you can say the latent heat and the specific heat formula. Mass is m, C is C only, delta T is 290 minus 273, that is the mass of the ice required into L. Okay, so the mass of the ice I can say is mc17 by L, or you can say 17 mc by L is the mass of the ice required. Okay, if you have any problem in any of the question, you can just comment below. I will try to resolve your query as soon as possible. So the answer for this question is A. Also you can find the PDF of this video. The link is given in the description. You can follow the link. You will be redirected to my website where you can find the downloaded PDF of this video. Okay, and all my videos, you can check my channel, you can check my playlist. All the PDF of all my videos are available on my website. Okay, now the next question, question number 9. Under which condition the pressure and the density for a real gas approximate to an ideal gas? So we have studied about the ideal gas, that is PV equals to nRT, but how the pressure and the density of the real gas will correlate, or it will be approximately moving towards the ideal gas. So we know that pressure has to be low and density should also be low so that the volume is maximum. So the low and low, that is a direct question. Okay, now the question number 10. These are the two flasks P and Q containing the ideal gas are connected by a tube with negligible volume. The volume of P is twice the volume of Q. Now if the volume of Q is V, then the volume of P will be twice of that of Q. P is held at temperature 200 Kelvin and Q is held at temperature 400 Kelvin. What is the ratio of the mass of the gas in P by the mass of the gas in Q? That we have to calculate. So in that case, using the equation PV equals to nRT, and N can be resembled with the mass of the gas. Now if the two flasks are connected with a tube, so we can say the pressure of P and pressure of Q will remain same. So PV equals to nRT, so the pressure is same, R is same, N can be written, or the mass of the gas can be written as V by T. So similarly I get this expression by using the ideal gas equation. Pressure remains the same. You can remain pressure for both P and Q is same because they are connected by a small tube. So this is the volume, you can just relate it now. Pressure of volume of P is 2V, temperature is 200 divided by volume of Q is taken as V and temperature is 400. So V and V gets cancelled, so 2 upon 200 times 400 upon 1, so you get 4:1, that is option C is the right answer. Okay. Question number 11 again. A transverse travelling wave is moving through a given medium. The graph is given for one instant for the displacement and of the particle with distance and displacement in the medium. The frequency is given as 25 Hz and the speed is 100 meter per second. What is the correct about the wave? So you can see here, this is given about the horizontal distance, velocity and all. So we can do one thing. Using the wave equation, first of all, let us calculate the wavelength. So wavelength will be speed, that is 100 divided by 25, that is comes out to be 4 meter. So this I can say, let us taking the point X, and this will be the wavelength of the given wave, which is 4 meter. So I can say each quadrant, that is this will be 1, this will be 1 and this will be 1 again, and this will be 1. So particle of X and Y are in phase? No, they are not in phase. The velocity of the particle at X is maximum. No, the displacement is maximum. Velocity remains the same. The horizontal distance between X and Z. So you can 1, 1, 1, that is 3 meter, that is the right answer. So C is the right answer for question number 11. The D, you can say the velocity of the particle at Y is 100. No, the particle velocity will remain the same. Okay, next question number 12. The graph shows the variation with time of a particle in again the travelling wave. What are the frequency and the amplitude? So you can see the maximum displacement from the mean position is your amplitude. So we can say it is 10 raised to power minus 6, that is nothing but the micrometer. So what is the answer? 2. So 2, either this or this. So let us check with the frequency. Frequency is measured by 1 upon time period, and the time period, you can say for one oscillation, let us start taking the point at from this point to this point. So you can say it is 1 upon 20 raised to power 10 minus 6. This is the frequency. So you can say F is equals to 10 raised to power or 100 into 10 raised to power. It is in kilo. So I can take this upon 20. So this is 50 kilohertz. So option C is the right answer. Okay. Now question number 13. An unpolarized light is incident on two polarizing filter X and Y. They are arranged so that the light emerges from Y has a maximum intensity. X is fixed, that cannot be rotated, and Y is rotated through theta in the direction of the incident beam in its own plane. What are the three successive values of theta for which the final transmitted intensity is a maximum? So we know that the maximum intensity will be there when they are in the same plane as that of the when it was initially. So you can say when I rotate it 180 degree, then the same intensity will be the maximum one which I got in the previous case. It is written now, I got the maximum intensity. They are arranged in so way. So to again getting the same intensity, maximum intensity, I have to rotate the Y filter with 180 degree. Then again 3 successive, add 180 more. So 180, then 360 and then 540. So this will be the right answer. Question number 14. A pipe of length 0.6 meter. I have drawn a pipe of length 0.6. This is filled with a gas having one end closed. So this end is the closed end. The speed of the sound in the gas is 300 meter per second. What are the frequency of the first two harmonics in the tube? Okay, so the gas is having a the speed of the sound in the gas is 300 meter per second. The question is asking what are the frequencies. So for one end open and one end closed, we have the formula that is lambda equals to 4L by n, where n is the number of the that is the first harmonic. For one end and one end open, we have n equals to odd number 1, 3, 5, 7 and so on. So this is the first harmonic, this is the second harmonic. So using these formula, okay, we can calculate lambda, and then by using lambda and the speed we can calculate the frequency. So the lambda for the first harmonic will be 4L by 1, and this is nothing but lambda we got is 4 times of 0.6, that is 2.4 meter. So we got frequency 1, that is 300 C by lambda, that is 300 by 2.4, which is 125 hertz. Similarly, we can also solve for the second harmonic 4L by 3. So lambda 2 will be 4 times of 0.6 divided by 3. So that will be 0.8. So 4 times 0.6 divided by 3 is 0.8, and then frequency will be 300 divided by 0.8, that you get 375 hertz. So the option B is the right answer. Okay, you have to remember this formula, and for one end open and one end closed, you have to use the odd numbers for the first, second, third and respective harmonics. Now the question number 15. A negatively charged particle in a uniform gravitational field is positioned midway. So this is a negatively charged, this is positive, this is earthed, so it is 0. So I can say if this is a positive charge, so mg will be acting in the downward direction due to the gravitational force, and a electric field QE, that is toward the positive plate because it is a negatively charged particle. Okay, so these two forces are acting. The potential difference between the plate can be adjusted until the particle is held at rest relative to the plates. What change will cause the particle to accelerate downward relative to the plates? Now we have to accelerate the particle in the downward direction. So we want this force to be maximized. So decreasing the charge on the plate. So the question is saying decreasing the charge. If I decrease this charge, so the magnitude of this force will get decreased, so there will be an overall force acting in the downward direction, so that will result in a downward force. So yes, option A is your right answer. Okay, now let us check for the others as well. Decreasing the separation of the plate. If I decrease the separation of the plate, we know the formula V equals to ED. If I decrease the separation, okay, so E will be V by D. So if I decrease the separation, electric field will get increased. So it will accelerate the charge in the upward rather than downward. So this is a wrong option. Increasing the length of the plate will have no effect. So again, this is a wrong. Increasing the potential difference. So if I increase the potential difference, then also the electric field will get increased, resulting in an increase in the electric force which is in the upward direction. So that is also a wrong answer. Okay. Question number 16. Two power supplies are provided. One is having a constant EMF of 24 and the other is a variable. With the two resistors, both power supply has negligible internal resistance. So what is the magnitude of P for the reading to the ammeter to be 0? Now I don't want any current in this branch. It is only possible when the voltage drop at 3 ohm is equal and opposite to the voltage provided by the variable potential EMF P. So just calculate using the Ohm's law. These are series. Let us forget there is no current, so the total resistance is 9 plus 3, 12. So current will be V by R, that is 24 by 12, that is 2 ampere. So if a current of 2 ampere is flowing, so the potential drop is 6 volt. So here also the potential drop will be, the potential provided by the EMF P will be 6 volt in the opposite direction. So the answer is 6 volt. Otherwise you can use the Kirchhoff law and taking the branch and the current this as 0, and you can solve for that, but that is a longer way to solve. But simply you can, using the potential drop method or the concept, you can just find the 6 volt should be the potential difference in the opposite order, so that it nullify the and therefore there will be no current flowing in the branch, in this branch. Okay, question number 17. When a wire with an electric current I is placed in a magnetic field of strength B, it experiences a magnetic force and the it experiences a magnetic force F. What is the direction of? So it is a direct Fleming's, Fleming's left hand rule. Sorry. So let us say if this is the direction of magnetic field and this is the direction of current. So using Fleming's left hand rule, we know that the FBI, force, magnetic field and current, so they should be mutually perpendicular to each other. So the force, the direction of the force will become, if I have drawn like this, then the force will be coming completely and out of the plane of my screen or of my iPad. Okay, so at 90° to the plane containing I and B, that we all know. Okay, now the question number 18. An object is hanging from a light string, moves in a horizontal circle of radius r. The string makes an angle theta with the vertical. The angular speed is omega. What is tan theta? So now we know that if it is hanging, there will be a tension T. So I can just draw this angle will also be theta if these two lines are parallel, interior opposites angle. So this is T. So resolving the forces, this will be T cos theta and this will be T sin theta. The weight mg, let us say, is acting in the downward direction, and now we can compare that T cos theta is nothing but the mg and T sin theta is the centripetal force m omega square r. Okay, so using this, dividing equation 1 by equation 2, sin T gets cancelled, sin by cos is tan theta, so I can write m omega square r upon mg. M to m gets cancelled, so we get tan theta as omega square r by g. That is option number A. So using this you can solve. Question number 19. So there are two routes for this to have decay for the nuclide X. Once through route 1 it is having first alpha and then beta minus, and the route 2 first it is having beta minus and then alpha. So if it is having, let us say, A is the mass number and atomic number, let us say Z is the atomic number. So alpha we know that A minus 4 and Z minus 2. Beta minus, there will be an increase in the as beta minus an electron has been emitted out, so there will be a overall positive charge, so that is Z minus 1 here and A minus 4. Similarly beta minus, if this is A Z, again this will be A only and this will be Z minus Z plus 1. Again then alpha, it will be A minus 4 and this will be Z minus plus 1 minus 2, that will be give you minus 1. So now look at the correct statement. Q and S are different isotopes of same element. Isotopes means having the same number of atomic number. So Q and S, you can say they are not having, Q and S, so you can say are different isotope of the same element. No, they are not different isotope, they are the same isotopes. Okay, because the mass number should be different, but there it is same, so they are of different. Mass number of X and R are the same. X and R mass number, you can see A and A, yes, so the option B is correct. Let us check for the C and D. Atomic number of P and R, P and R are same. No, that is not same. X and R are different isotope of the same element. X and R, X is here, R is here, different isotope of same element. No, the isotope, they are not having the same isotope, so that is also incorrect. So only option B is correct. Okay, now the question number 20. The proton, electron and alpha particle are at rest. Which particle has the smallest magnitude of ratio of charge to mass? So alpha particle, proton and electron, these are the charge, these are the mass, and this is charge by mass ratio have already been placed here. So we know that alpha particle is having 2 proton and 4 times the mass of hydrogen atom. So this is plus 2 4. So E by m we got 1 by 2. Similarly for the magnitude of the charge on electron and proton is plus 1, mass is taken as 1, the mass of one proton is taken as 1. So or that a hydrogen atom is having 1 proton, we can say. So 1 and 1 by 1 is 1. Let us check for the electron. Electron has a charge of minus 1, but when we consider the mass of the electron is very less than that of the mass of a proton, which is 1 by 1836 approximate. So by taking the ratio, we got maximum for the electron and minimum for the alpha. So the smallest for alpha and largest for electron. So the option A is the right answer. You have to just check the charge by mass ratio, and just you can check which one is having the largest and which one is having the smallest. Okay. Now question number 21. The gamma radiation is deflected by a magnetic field. No, it is not, because gamma radiation is having no net charge. So we can say it is not deflected by magnetic field. Yeah, it affects the photographic plate because of fluorescence, you can say, is being created for the photographic plate when a gamma radiation is being incident over the surface. Okay, now the question number 22. The equation of motion for uniform acceleration. This is a TOK question. So applied to all acceleration, no, not mandatory, cannot be proved mathematically, it can be proved. Relate forces to other quantities in mechanics, not necessary, but developed through observing the natural world, yes. Okay, so the answer is D. Now the next is specific energy is the energy per unit mass. So the energy per unit mass is joule per kg, and energy density is energy per unit volume, that is joule per meter cube. So option B is the right answer. Question number 24. The function of the moderator in a thermal nuclear fission reactor. So when we were dealing with the nuclear fission, we know that the ejected nucleon or the neutron which is ejected in the nuclear fission is having a very high amount of kinetic energy. So we add a moderator of generally a hard water or cold water, you can say, or an ammonia is added in order to slow down the speed of the ejected neutron. So moderator works as to decrease the kinetic energy of the neutron emitted from the fission reaction. So all other options are incorrect, only option A is correct. Okay, next is your 25. What is mean by the statement that average albedo of the moon is 0.1? So in the astronomy chapter, we know that albedo is the factor which defines that how much power of the radiation has been scattered upon the total amount of radiation incident on that particular planet or the surface. So the 10% of the radiation incident on the moon is reflected by its surface. That is what is mean by albedo of 0.1. Okay. Question number 26. An object undergoes a simple harmonic motion of amplitude x0. What is when the displacement is x0 by 3, the wall speed is v. What is the speed of the displacement when the displacement is x0? So please make sure that here the displacement is x0, that is the amplitude only, and we know that when the object is in the SHM, it is at the maximum amplitude, then the velocity at that particular instant, for example this is the SHM and this is the maximum amplitude, so at this the velocity will be 0. So it is a direct question, no need to do any calculation, just read the question very carefully. Okay, now the 27th question. The frequency of light is 500 incident on a single slit diffraction to form a diffraction pattern, and the angle for first diffraction minimum to the central is given in the radian. if I have changed the frequency to 750, what is the angle between the first diffraction and the central maximum? So using these two equations, this is already provided in your physics booklet. So theta is lambda by t and c is f lambda, we know that. So we will just use these equation. So I can write using this equation as like theta, or I can say theta 2.4 into 10 raised to power minus 3 is lambda, or lambda can be replaced as c by f, because lambda can be written as c by f. Okay, so c by f times b. B is the slit width, that is remains same for both the cases, and theta 2, or let us say theta 2, we have to find out. That will be again, and here the frequency for this is given in the question, which is as 500. So c is the speed of light, that will remain the same. Upon now the frequency is, this is terahertz, that is same, so it will doesn't matter, it will just cancel it out. So 750 times of b. So now you can see here CB gets cancelled. So I can write 2.4 into 10 raised to power minus 3 upon theta 2 will be equals to 750 upon 500. So if you solve this, you will get 2, 3. So this theta 2 will be 2.4 into 10 raised to power minus 3 times 2 by 3. So 3 is 0.8, 0.8 into 2 is 1.6. So option A is the right answer. Okay, you have to just do the simple calculation. Use these two formula, combining these two formula which is already provided in your physics booklet. Now question number 28. A light of wavelength lambda is normally incident on a diffraction grating of spacing 3 lambda. What is the angle between the two second order maxima? Okay, so this is the second order maxima, this is also second order. So the question is asking between the angle between two second order maxima on the screen. So we know that n lambda equals to t sine theta. So it is second, so 2 lambda equals to, spacing is given as 3 lambda sine theta. Using this we get sine theta as 2 by 3, or you can say theta inverse, theta equals to sine inverse 2 by 3. So the total angle is 2 theta. So 2 theta will be twice of 2 times of sine inverse 2 by 3. Okay, so the option is C is the right answer. Question number 29. Sea wave move towards the beach at a constant speed of 2 meter per second. They arrive at the beach with frequency of 0.1 hertz. A girl on a surfboard is moving in the sea at right angles to the wave fronts. She observed that the surfboard crosses the wave front with a frequency of 0.4 hertz. So this is the formula from the physics booklet. So you can use this formula. Now we can see here the frequency observed, that is the f dash is greater than the f. So we will use the positive sign for the numerator one, because then only the observed frequency will be greater than the original frequency. So using this formula, 0.4 equals to 0.1 times speed of the is 2 plus u naught by 2. So solving this, you can get 4 times 2, 8 minus 2 is nu naught, so that is 6. Now it means plus means they are, the relative speed is separation, so they are moving in opposite direction. So the speed of the wave in towards the beach and the girl is moving away from the beach. Looking at the option B is the right answer. Now question number 30. The gravitational potential is V at a distance r above the surface of a spherical planet of radius r. Let us say this is my spherical planet of radius r from the center, and we have to find the potential V at this point, which is again distance r from the surface of the planet. So V using the magnitude only, that is gm upon 2r. Why I have taken 2r? Because it is distance from the center of the planet. So from the center of the planet, the total distance is r plus r, that is 2r. So this is given V. Now what is the gravitational potential at a distance 2r above the surface of the planet? Now I have to find a distance, let us say at V dash, this is again r. So V dash is gm upon 3r, r plus 2r. So if I want to right answer in terms of G. So Gm upon 2R is V. So V dash is 2V by 3. R and R get cancelled. So 2V by 3, that is option D is the right answer. Okay. Question number 31. The force acting between 2 point charges is given by F Q1 Q2 K Q1 Q2 upon, if the distance is x, then x square. Now the distance changes from x to 3x, so Q1 Q2 upon 3x square. So that will be F by 9. Simple. Okay, because K Q1 Q2 upon x square is replaced by F. So new force F dash will be F by 9. Okay, this formula is also given in your physics booklet. You can use it. Now question number 32. An electron enters in a uniform electric field whose direction of velocity is not parallel with the electric field lines. So what will be the direction, or what will be the path of the electron entering the field? So we know that on electron opposite, in the direction opposite QE, force will act. So if the object is moving in this direction, force is in this, so it will travel a projectile motion that is similar to a parabolic path. Okay. Now the next, x and y are the two coils having in the same plane passing to the same common axis. A constant direct current is flowing in the coil y, which is shown here. The first x is moved towards y and then it is moved away from the y. We have to find out the direction induced, that is nothing but the Lenz's law. Okay, so we know that when it will move towards y, it will oppose the cause of the motion. The current will flow in such a direction that it will oppose the cause of the motion. So if it is moving in this direction, it will move opposite, or you can say opposite to the direction of y. And when it move away from the y, the current will move in such a direction it won't move. So it will attract, so it will move in the same direction as that of the y. So when it moves towards the y, it will oppose it, and it moves away from the y, it will be in same direction. So the option C is the right answer for this question. This is from Lenz's law. Okay. Question number 34. A coil is rotated in a uniform magnetic field. The alternating EMF is induced in the coil, that is the Faraday's law. What is the possible phase relation between the magnetic flux through the coil and the induced EMF in the coil when the variation of both the quantities are plotted with the same time graph? Now we know that from this physics booklet, again from the Faraday's law, the induced EMF is directly proportional to the rate of change of magnetic flux. It means that when the change in the magnetic flux, rate of change in the magnetic flux is maximum, or the slope is maximum for delta phi by delta t, that is the change in the flux, at that instant the EMF will be the maximum. So you can see in all the graphs, if I draw the tangent at this point, you can say this is the slope, we are getting the negative slope, that is the maximum, and at this maximum I am getting the EMF, which is the maximum EF. So only this option B supports this answer. Rest all, if you see the options, you can see at this point the EMF is not maximum. The solid line is denoting the EMF and the dotted line is denoting the magnetic flux. So the change in magnetic flux, that is the slope at this point, is this, and this is the maximum slope, the negative gradient. So at this point the EMF should be the maximum induced. So this is only B option is supporting. Rest all, you can see it is the negative and it is at the same, so it is not supporting the answer. Now question number 35. A capacitor is having a capacitance C as 1 microfarad and having a charge of 15 microcoulomb. The capacitor is discharged with a resistance of 25 ohm. What is the maximum current in the resistor? So we know that V equals to Q by C. Q is 15 and C is 1. So we get V as 15. So using Ohm's law, I can write I equals to V by R. 15 by 25 is 0.60 ampere. So that is the right answer, C, easiest one. Now the bridge rectification question is given here, and alternating potential difference is applied between M and N. Which of the statement about the circuits are correct? So when P conducts, so let us say starting with this positive and this negative. So this is positive, so this is reverse bias. Initially it is reverse bias. This is forward bias, so current will flow like this. It will go like this, then it will go. So the first statement say when P conducts. So when P conducts, Q does not. Yes, because one is forward, one is reverse. So when P is conducting, Q will not conduct. So this is the right statement. When S conducts, neither P nor R conducts. Yes, so when S is conducting, it means that it is in forward bias. This is in reverse bias. So yes, this is also true. So we can say second statement is also true. The direction of conventional current in the resistor is from left to right. Not exactly it is always from left to right. No, it can also be from right to left. So you can see it is from right to left going on. So this is the incorrect statement. So only 1 and 2 are the correct statement. Okay. Now question number 37. This is from the direct question from quantum physics. An electron of low energy is enclosed with a high potential barrier. What is the process in which the electron can escape? So that is only because of the quantum tunneling. Question number 38 now. A beam of monochromatic radiation is made up of photon of momentum p. The intensity of the beam is doubled without changing the frequency. What is the momentum of each photon after the change? Now we know that if we increase the intensities, there is no effect on the frequency, as energy is directly proportional with the frequency. And energy can be written as half mv square. So if there is no change in frequency, there is no change in velocity. If there is no change in velocity, then there will be no change in momentum. So the intensity has no effect on the momentum. Whether you double it or you reduce it, it doesn't affect on the momentum. So option B is the right answer. Now the three observations of the behavior of the electrons are given. Which observation are evidence that electron behaves as a particle? Now we know that electron behave as a particle as well as wave. It has a dual nature. So we have to support with the given statement which supports the particle nature. So let us go through each statement. Electron emission as a result of photoelectric effect. So we know that photoelectric effect is an evidence of a particle nature of electron. So it supports, yes, first is correct. Electron diffraction. Diffraction is, student please note, diffraction is the phenomena related to the wave nature of electron. So this does not support. Third, emission of radio waves as a result of electron oscillating in a conductor. Yes, this is a particle nature, which proves the that electron behaves as a particle. So yes, only 1 and 3, that is option B, is the right answer. Okay. Now the last question. A pure sample of a radioactive nuclei contains N0 atoms at t equals to 0, and when t is at time t, the N atoms of the nuclei remaining in the sample. The half-life is t half. These are the formula already given in the physics booklet. What is the decay rate of the sample proportional to? Decay rate is nothing but the activity at which rate the decay is going on. So we know that activity is lambda times m, so activity is directly proportional to n, that is option A, the simple one. Or using this formula, A equals to this can be written as n using this formula, so A is equals to lambda. So activity is directly proportional to the number of nuclei present in the sample for decay. So this is option A. So we have completed here for the HL Paper 1 November series 2019. If you have any doubt, anytime you can comment below. Also, you can find the PDF of this video in the link given in the description. You will follow to my website where you can find the downloaded PDF of all my videos. You can check the playlist also. Also, if you want any other paper to be solved, you can comment below. I will solve it as soon as possible. Thank you. Please, if you like this video, please share with your friends and the classmate. Or if any suggestion or feedback you want to give, you can mail me to my email ID given in the description. Thank you.